In this video, I'm going to be talking about the similarity postulates. So, just like the congruency postulate, there's no proof for this, just assumptions. Assumptions to solve problems, to make a point. And there's the angle postulate, angle similarity postulate, side postulate, and a side angle side similarity postulate. And let me teach you a little bit what they are. So, similar means, in geometry, similar means that two shapes are the same shape. They don't necessarily have to be the same size, but they could be. If two shapes are the same shape and size, they're congruent and they're similar. But if two shapes are the same shape but not the same size, then they're just similar and they're not congruent. So, how can they be the same shape? How can they be similar? Let's say you have two triangles and you've measured that they have an angle and an angle and an angle that are congruent. Then they must be similar or congruent, but they might not be congruent unless you follow the congruency postulates. But they are similar. You know that because, let's say this is X, Y, Z, X, Y, Z. We know that this is, let me relabel this, A, B, C. X plus Y plus Z is equal to 180. A plus B plus C is equal to 180. So, we know that if you have two, let's say you have two that are the same, then you can cancel these, and Z is equal to 180 minus X plus Y, and C is equal to 180 minus A minus B. This is the minus, not a plus. This is also a minus. And since X and Y and A and B are equal, 180, this is basically saying 180 minus A plus A minus B, or minus X minus Y. This is saying minus A plus B, A minus B, or A minus X minus Y. So C and Z are equal. So, given that they're equal, we know that A plus B, that C and Z must be equal, so that the two triangles must be similar. So they can have the same angles. If all of the angles of the triangle are similar or are congruent, the two triangles are similar. And unless they have the same congruency postulates that they follow, they're not congruent. Now, let's go to the side postulate. Let's say I have a triangle. I have two triangles. Let's say I have this length is 1, this length is 3, and this length is 5. And let's say this length is 5, this length is 9. Let's see, no. This length is 15, and this length is 25. So the side postulate and similarity says that the ratio between this side and this side, 5/1, is equal to the ratio between this side and this side, 15/3. And that these two ratios are equal to the ratio between this side and this side, equal to 25/5. And this just goes to 5, and this just goes to 5. So you can't really prove that. You have to assume it. And I encourage you to get a protractor and a ruler to prove it. And you can solve many problems with knowing these similarity postulates. And the next postulate, that's the side, side, side. The next postulate is the side angle side. So, if you know, let's say we don't know this side, and we don't know this side, but we know this angle and this angle are equal, then we know this side, this side, this side, and this side. If this side and this side, 5, 1, the ratio between that side and that side is equal to the ratio between 15 and 3, or this side and this side, and the angle in between these sides are congruent, then the triangles are similar, they're the same shape. So, yeah, they're the same shape. And that's the similarity postulates. Let's move on.